This lesson is about domain and range and interval notation. Just to recall, a function is a set of ordered pairs in which each x-coordinate has exactly one y-coordinate. All equations give a relation, but a function's special in that each input, or x value, produces exactly one output. Domain and range. The set of all numbers that are the input values are your domain. The set of all numbers that are your output value are your range. Okay, interval notation. Using greater than and less than signs is kind of messy, so interval notation is like nice and compact and great. Anytime you have infinity, which means you're going on forever and ever, you're going to use an open bracket. Anytime that you don't want to include an endpoint, you use an open or soft or rounded cutie pie bracket. When you want to include something, you do a nice squared off bracket. Good? So the inequality 2 less than or equal to x less than 5 can be expressed like this. We want the 2, we don't want the 5. The inequality x greater than or equal to -7 would be the nice squared off bracket for -7, but we want it to go on forever. So it's a soft bracket because you can't pin infinity down. You just can't. Okay, let's do the next of examples, and I think it's going to clear it up. We're going to find the domain and range of the relation and then determine whether it's a function or not. So the domain are your x values, your range are your y values. So if I look at this, this guy is really going on and on forever and ever. So it's going to cover all of the x values. So my domain will be -infinity, infinity, nice and soft. And what that means is all reals. That's really what that means, all real x's, x values. Good? Now the range, the highest y value here is, it's approximately 6, I would say. And everything else is below that. So the highest y value is a 6, so we're going to bracket it off at the high end. The highest value always goes to the right. The lowest value will be -infinity, and it's a nice soft bracket there. Good? So really what that means is y is less than or equal to 6 in inequality notation. Now, is this graph a function? For every x value, is there exactly one y value? Yes, because I could use something called the vertical line test. And that says that if you draw a line at random, vertical line, anywhere through the graph here, it hits the graph at most once, and these are yay, yippee. I only have one y value associated with any given x value. So yes, this is a function. Yippee-i-o-ki-yay, and then we do this with the little, okay, do the next one. Let's talk domain and range here. This is supposed to be an ellipse, but let's take a look over here. I'm going to draw this down and this down. Good? So for the x values, the lowest is about -2, and the highest is about 6, but I want to include them, so I'm going to do -2, 6, nice sawed-off brackets. The range, the lowest y value, and I'll do that in red, seems to be like 3, and the highest seems to be 7. So we're going to go from 3 to 7, include. Now, is this the graph of a function? Absolutely not, because if I draw a line, even once, a vertical line, it hits this graph in 2 places. That means when x is equal to 4, it has 2 y values, this one and that one, so that's bad. So this is not a function. If I could spell, that would be really super great. Okay, so now you guys, believe it or not, that's it for this section. You just do your domain, your range, you figure out whether it's a function, you move on, okay? So now you can do the My Math Lab section associated with this. Good luck, stay strong.